When you search queue data structure in Google, these are the images that will pop up. The main idea or concept behind the queue data structure is very much similar to what a queue means in everyday life. The data is organized through a line or a queue. The most common example on how to explain queues is how we form lines in real life when we are waiting for something. Queues in computer science or in a context of data structure is basically just the same as what queues are in real life. In computer science, queues, just like stacks on the previous video, is a data structure. It is just another way of storing and processing the data. The way that the data are processed or stored are organized are just like queues in real life. Let's say, for the sake of an example, let's say you're given the data 1, 2, 3, 4, and you want to store it in a queue data structure. So what happens here is that the first one goes to the first in line. Then when we add another element, the second element goes behind the first one, and then we add another one, and then we add another one, or should we say we put the next element behind the other one. Queue data structure, as mentioned, can be taken quite literally as what queues are in real life. Let's say in a line of people buying groceries, we put the first one to arrive in the front of the line, and then when we add another data, or should we say when another person arrives, the data is added behind the first. Since the first person is in the first in line, this person will also be the first one to be accommodated and the first one to go out. This is what we call as the first in and the first out principle. The first one to go in goes first. The one who will also be removed first is the first one in line. The first person who goes in, he will also be the first person to go out. Now that we understand what stacks are, let's try and implement it. Here, I have here a code. It's my version of a pseudocode of how to implement a very simple queue through an array. But let's not focus on that. Let's translate the code in a more natural way. For the sake of an example, let's say we have a store. We have a checkout counter. What we need to do now is to create an instruction of how people should fall in line so that there will be order in that store. So let's go back to our code, and line 1 here basically says that we need to label the available spots for the people to fall in line. So we create spots, and let's label them starting with 0. For the sake of explanation, let's say that we need to tell the cashier that she should be mindful of who the first one is, or to know where the front is. For now, since there are no people, the cashier identifies the front as spot number 0. And let's also say that we need to hire a guard who will serve as a pointer, or in our situation's case, he just checks and identifies where the end of the line is so that there will be order. For now, the guard identifies the end as spot number 0, same as where the front is, since there are no people yet. Now going back to our code, the next instruction that we're going to do is when someone wants to fall in line, we're going to say to that person that he or she should ask the guard first where the end is so that she or he will fall in line in that spot. So let's say when one person arrives, he asks the guard, then the guard says the spot that he should be on is on spot 0. So since one person already fall in line, the guard will re-identify which the end spot is. So the guard will re-identify it from 0 to 1. The guard will re-identify the end spot to be spot number 1. Then let's say another person also wants to fall in line. So we go back to our instruction. He or she will first ask the guard where the end spot is. And now the end spot is on spot number one. So that person will go to spot number one. And after that, the guard will re-identify again where the end spot is since there's another person that came around the line. So the end spot now will be spot number two. Now, going back to the code, the next instruction that we're going to do is that when we want to remove someone or the data in the queue, or in our case, the person in the line, we ask the cashier where the front is. Then the one who is identified in the front spot will be removed. In our case, the front spot is spot number 0, so the person there will be removed. Then, when the person is removed, the cashier then identifies where the next front spot is since the first spot was already used and the element there is removed. So the next front spot will be the next person in line. So that's basically how queues work as a data structure. This visualization is very much similar to how queues are implemented in formal code. In a computer science explanation, there's a pointer and an array in the memory. The spots are the space in the memory, the cashier and the guards are the pointer. And now some applications or examples of data structure in software are, for example, operating system scheduling or any type of scheduling in a software system. And there's also the keyboard buffer or any type of how computer receives commands from external machines like keyboard and mouse.